This short video is going to focus on properties of division. And you know, I love properties. I love thinking about how numbers relate to one another. So there's four common properties we've talked about, and we'll see which one of these, or ones, are true in division. So the first one we've talked about is closure. Our whole numbers, since we're talking about whole number properties, our whole number is closed under division. What that means is if they're closed, if I take any two whole numbers, then A, let me get my pen going here, then A divided by B better be a whole number, is a whole number. So if that's true, it should be true for all whole numbers. If not, I should be able to come up with a counterexample. Okay, so a counterexample is just one example that shows it's false. Well, sometimes it's true, right? 6 divided by 3 does equal 2. That's a whole number. 48 divided by, let's say 12. That equals 4. That's a whole number. Sometimes it's true, but here's a counterexample. How about, let's just reverse this, 3 divided by 6. 3 divided by 6, if you do that, say, in a calculator, or as a fraction, that's going to be 3 over 6, which equals 1/2, which is not whole. So what does that say? That says that division is not closed under, so not closed under, or whole numbers are not closed under division. All right, are whole numbers commutative? Okay, let's see. We've kind of answered the question up above. We said, if they're commutative, then for any whole numbers A and B, that A divided by B has to equal B divided by A. And we've already answered that up above. We said that 6 divided by 3 equals 2, but 3 divided by 6 equals 1/2. So we found a case where A divided by B does not equal B divided by A. This is an example where you'd actually have to work hard to find a case where it does work. But remember, to be false in mathematics, you just need one case where it's false. So this is false. It's not commutative. Here's a case where it does work, actually. It's one of the cases where it is commutative, is if A equals B. So for example, 2 divided by 2, well, that equals 1. And if I switch them, I have 2 divided by 2, which is also 1. So occasionally when A equals B, it works, but it's not always true, so it's not commutative. Associative. All right, so associative property, let's look at, say, 24 divided by, let's say 8 divided by 2. And let's group it like that first. Remember, associative is about grouping. Does that equal 24 divided by 8 divided by 2? Can I group them differently and get the same answer as you can in multiplication or addition? Well, let's see, 24 divided by 8 divided by 2. So 8 divided by 2 is 4. That's 24 divided by 4. And that equals 6, okay? So let's see if we get 6 on this other side. So 24 divided by 8, that's 3. 3 divided by 2 is not 6. That's, what is that, 1.5. So again, if you can find one case, just one case where it's not true, then it's not associative. Here's a case of numbers. It's a counterexample where A divided by B, so it would be, the statement would be, does A divided by B divided by C, does that equal A divided by B divided by C? That's the case. That would be the statement if it's associative. And the answer again is no. And it looks like we're sort of striking out a lot here. Finally, identity property for division. Is there an identity property? You might think, well, yeah, 1, right? 1 would be an identity property because 24 divided by 1 equals 24. Okay, that's good. I divide by 1, I get 1, 106 divided by 1. That also equals 106. That's promising. That looks like 1 should be an identity. The problem is with identity properties, the reverse, the opposite has to be true. In other words, it doesn't matter which way you operate with this for an identity. You know that 1 times 3 equals 3 times 1. Okay, that's identity for multiplication. For addition, 0 plus 6 equals 6 plus 0. In other words, you have to be able to reverse it. 24 divided by 1 does equal 24, but 1 divided by 24 equals 1 over 24, which is not equal to 24. Okay, so it's sort of partially true. It's a half identity, if you will, but it doesn't always work. So there is no identity element in division. Finally, let's tackle that thorny issue of division by 0. And I know that so many people say, it's a common thing, oh, division by 0 is undefined. They'll say, oh, it's undefined. Well, what does it mean that it's undefined? To think about that, you have to think about what is the definition of division. Here's a definition of division. And again, the definition is division is defined as multiplication. A divided by B equals C if and only if. Now this is key, the part that we've sort of glossed over. If and only if, and I'm going to get a different color going here. There you go. If and only if, I'm going to look at two things. There exists a unique whole number. Those are both key words. A unique whole number, C, such that A equals B times C. So that's what it means to have a division that's defined. Okay? You know why? We've talked a little bit about this before. We said, okay, why is 8 divided by 2, why does that equal 4? Well, that's because this is the missing factor model, because 4 times 2 equals 8. That's what it means. And there's no other. So there is a number. There is a number that works, which is 4. And there's no other number. There's only 1, right? So this focus on division by 0, there's actually two cases of division by 0. First, when you have a number that's non-zero divided by 0, what does that equal? Well, let's assume it equals something. So n divided by 0, let's say that equals some number c. Could it equal a number c? Remember, n is not 0. Well, by the definition, n divided by 0 equals c if and only if 0 times c equals n. Remember, n is non-zero. It's a 2 or a 4. It's something that's not 0. So can you find any number c such that 0 times c equals n? No, you can't. So no c exists. In other words, n divided by 0, there does not exist a number that works. So that means that n divided by 0 does not meet this definition, because there does not exist a c such that a equals b times c. There is no c such that n divided by 0 equals c. All right, so that's case 1. Case 2, which I think is a really cool case, is what is a 0 divided by 0? I'll have so many elementary students tell me, oh, that must be 1, because they get used to 1 divided by 2 divided by 2 is 1, 3 divided by 3 is 1, 0 divided by 0 must be 1. And I always challenge them to put it in your calculator and see. Well, 0 divided by 0, what does that equal? Here's my claim. When kids tell me that equals 1, I say, you know what? You're right. Does 0 divided by 0 equal 1? Let's see. Does 0 divided by 0? That's true. Look at the multiplication. If and only if 0 equals 1 times 0. Yeah, that must be true. 0 divided by 0 must be 1, because this is true. But then I'll challenge them. I'll say, okay, well, what about this? I claim when I was traveling abroad, I went over to France. And in France, they told me that 0 divided by 0 is 2. And I said, how can that be? I think it's 1. Well, here's how they think. They think that 0 divided by 0 is 2. Well, let's look at the multiplication problem. If and only if 0 equals 2 times 0. Well, that's also true. Oh, but then maybe we travel even further. We go down into South America, and in South America they claim that 0 divided by 0 equals, they like the base 60, so that's 60. Does 0 divided by 0 equal 60? Here's their reasoning. Yes, it must, because that's true if and only if 0 equals 60 times 0. Each of these is true. So does 0 divided by 0 equal 1? Yep. Does it equal 2? Yep. Does it equal 60? Yep. It equals anything you want it to. In other words, there is no unique number C. It's not unique. It could be anything. There's two parts to that definition. There must exist a C, and that C must be unique. In this case, it is not unique. C can be anything you want it to be, which means, again, that 0 divided by 0 does not meet the definition, which means it's not defined.